Hello class, this is the video for section 2.5 for this week. Notice that we are covering 2.5 before 2.4. Okay, so there we go. Here are the learning objectives. We are going to use some graphing techniques, vertical and horizontal shifts, using compressions and stretches, and then reflections in the X and Y axis. Okay, so horizontal shift and then vertical shifts. Here are the examples. But in any doing these graphs and able to use these techniques, one must know the basic word functions. All right, this is what you learned from Math 96. So I'm going to go over about 6 of them, and notice that for every problem given here, you must first identify the basic function. Okay, sometimes they will tell you, other times they will not. So let's look at the first one, which is f of x is equal to what? X squared. Now we know that x squared is what? It's a quadratic function. It opens upwards. So the basic function for that, okay, let's if you pick some points here, say 1 and 2, and let's call this this is 4, this is 1, and then we have -1 and then -2, right? So if x is 1, y is 1. If x is 2, x squared, 2 squared is what? Is 4. So it's going to be here. And if x is -1, if you square this, you also get 1. And if x is -2, you get what? +4. Okay. So, and then if x is 0, you get what? 0, 0. So there is a turning point as that. Okay. This is the parabola what? Function. So it's coming this way and it turns, okay, and goes up like that. Okay. So this is the basic function. It's what? It's a parabola. Okay. Now, the second one is what? A cubic function. Okay, let me erase there. I want this to be straight. Okay, so you have a cubic function, right? And you have the x-axis, and this is your y. Now we know that if x is 0, y is also going to be 0. If you evaluate a function f of 0, you get 0. Okay, so that's the point here. Now if x is 1, you also get 1. If x is 2, right? Let's say this is what? This is 8, because 2's cube is what? Is 8. So this goes to, these are the points, and x is 2, it goes to what? It goes to what? 8. Okay. So that's the point. And then we also have what? -1, and then say we have what? -8 there. Okay. So if x is -1, and then what? -2. And both of them, this is what? -8, and that is what? 2. So the graph of this is coming this way, goes through that, and then 0 and goes up again like that. Goes to this point. So it goes up like that. So this is what? X cubed. Now C, that's a square root of what? X. Now square root of x, here we consider the what? A positive. Okay, only the positive, not the plus and minus. So we have what? 1, 2, say, okay, I'm going to pick basic so that you don't have decimals, right? So if we have 4 and then 1, if x is, this is 1 and 2, 1 square root of 1 is 1, so that gives you this point. And then square root of 4 is what? Is 2, so that gives me that point. X is 0, square root of 0 is what? Is 0. So the graph starts from here and goes like that. Okay, so this is your y, and that is that's your x. And then for the cubic function, the cube root, okay, this is the cube root, okay, cube root what? Function. Well, for that, it's going to behave like what? It's similar to this, but it's also, well, you go back to B, you notice that this is a symmetric with respect to the origin. Okay, this is not, that is symmetric with respect to y-axis. Okay, this is y-axis. Now let's see what happens with the cube root. Let's pick f0, 0. Okay, if x is 0, cube root of 0 is 0. Now if x is 1, cube root of what? That is also 1. Okay. Now I'm going to pick a very good point. Let me pick a positive 8, because if I find a cube root of 8, it is what? It is 2. Okay, so that I don't deal with what? I just need a few points. Okay, this is 8 is what? Positive what? Positive 2, which is right there. Okay, and then you have what? Negative 1, and then let's have negative 8 on this side. The negative 8, this is what? Negative 1, and that is what? Negative 2. So we have this point, and then we have what? That point. Okay, so the graph of the cube root function, it goes like this, and then like that. Okay, so, all right, it is closer to the what? The x-axis than what? The cubic function, right? The cubic function moves away from the x-axis like that. Okay, now let's look at the others. Two more. We have the absolute value function. So the absolute value function, we want to have what? This is your x and y coordinate system. Okay, let's pick 1 and 2, and 1 and 2, and then the 0, 0, negative 1, and negative 2. Okay, because if you take absolute value of a number, you get positive all the time. So 0, 0 is 0, 1, absolute value of 1 is 1, so which is this point. Absolute value of 2 is also 2, so that is the point. Okay, on the other hand, the absolute value of negative 1 is 1. Okay, so it is symmetric with respect to what the y-axis. Okay, and then absolute value of negative 2 is also what? Positive 2. Okay, so if you take a straight line and draw a straight edge, straight line, a straight edge to draw these lines, so you have that. Okay, so this is the what? The absolute value function. Now, for this is called the reciprocal. Okay, reciprocal what? Function. Okay, so I have my x and y axis, and then I have x and then what? Y. Okay, if x is 1, okay, let me just straight this, let's put 1 here. If x is 1, just 2 points there, 1 and 2, this is 1 and this is 2. So if x is 1, 1 over 1 is 1. So we have this point right here. And then if x is 2, the y is well, one half of that. So that is this point right here. That's half of this. Okay. Now the x axis and y axis are what? Asymptotes. Okay. X axis and the y axis are asymptotes. Okay. So we will talk more about this when we get to chapter 4, I believe. So this graph, it goes like this. Okay. And on this side, and then if you have -1 and then -2, you still have what? -1.5. So you have this is 1, and then half of that is that. So this is going like this. Okay. It does not touch the what? The y-axis, so it goes down. Let me erase this part and draw a curve nicely. You have this. So you have a -1. So you have this point. It goes like that. And then it doesn't touch the what? Okay. So this is the graph for that. Now, these 6 basic functions, you must know them so that you can be able to do the problems in this section. Right. Now, let's go to the first technique, that is vertical shifts. Vertical shifts. Okay. Now, we have upward shift and then downward shift. Now, for any graph, okay, which is of the function y is equal to the f of x plus a certain what plus k. Now, if it is positive k, the shift is what vertical by it goes up k units. If it is negative k, it goes down k what k units. Okay, so depending on the basic function, if it is plus say 2, then it's going to shift up 2 units. And then if it is minus 2 or negative 1, it goes down 1 unit or negative 2 units downwards. All right. Now, let's look at this example. It says that sketch graph of what a, f of s is equal to square root of what x plus 2. Now notice that this 2 is not under the radical sign, okay? So it's like plus what? Plus k, okay? Plus k. So in this case, my k was 2. And then the other question, the b part, my k is what? Minus 2. So we have minus what? Minus k. All right. So then let us look at the graph for that, okay? So we need to identify the basic what? The basic function. Okay, so what is the basic function? Okay, what's the basic function? So first, it says that to graph this, always start with what? The basic function, which is the square root what? Function. All right, so our basic function is what? Y is equal to square root of x, or f of s equal to what? Square root of x. Okay, now we drew this one. So first, for the a part, okay, which we are given that f of x is equal to the square root of what? X plus 2. Okay, now because it's plus 2, what we do is that this is what? This is vertical shift. Okay. Okay, how many units? It goes up to what? 2 units. Okay, so for part B, part A, that's what happens. So we draw this function, square root of x, and then we move it upward 2 units. Okay, then for part B, which is what? F of x is equal to the square root of x minus 2. Okay, what happens? This is also what? Vertical shift. Okay, vertical shift down to what? 2 units. Okay, so we're going to draw this, both of them. I'm going to draw both of them so that I see how we move them. That's how we shift the graph. So first, we want to draw the basic function, picking few points on it. Okay, so I'm going to do, let's draw our x and y axis. This is a 1 and then 2. Okay, and then say 3. So I'm going to pick just 1 and then 2, 3, and 4. Okay. All right. Now, the basic one is, that is square root of what? X. Okay. We have this graph, the origin, and then when this is 4, okay, it is 2. So 2 and 4, that's what they mean. So the graph of the basic one is this. This is your what? F of x is equal to the square root of what? X. Now, I'm going to change the color. Okay. If I'm going to shift this, okay, this point is 1, 1. And this point is what? 4, 2. Now, for the first part A, we have to shift this what? 2 units up. So the origin becomes what? 1, it goes up 1 unit. So this point, which is 0, 0, now becomes what? 0, what? 0, 2. So that's that point. Then this also goes up 1 and then 2. So it becomes, still S coordinate is the same, but the Y coordinate is what? Is 3. And then we also have this goes up 1 and 2. Okay, this is, don't forget, this is 4. So the coordinates of the point becomes what? 4, 4. Okay, so if you want to graph this, Okay, it's going to start from here and goes like that. So it's going to go this way. So this is your what? The f of x is equal to the square root of x plus what? Plus 2. Okay, so it's the same graph. It doesn't look the way the graph is. Let me erase and see if I can have a better graph there. Okay, now let's try it again. Okay, we're starting from 0, 0. Because it's not drawn to scale, it's going to be harder. So we have this and goes like that. I'm going to put it up there. Okay. So we have this. All right. So that's the graph for that. Now, the second part, part B, okay, if I use a different color, okay, let me use, say, green. Now, part B is what? We go up, we go down this time. So this point becomes, this is a -1, -2, -3, and -4. Okay, so this -1 move down, 1, 2. So it comes to this point. So the point becomes 0, -2. Because we are moving the original, the f of x equal to square root of x down 2 units. Okay, so now let's pick this point. It goes down 1, so that's 1, it goes 0, and then 1 again. Okay, so that becomes, the point is, the coordinates will be 1, -1. Okay, then this point, which is what, 4, 2, also becomes, it goes to 1 and then 2. All right, then that point becomes what, 4 and then what, 0. And so to get this graph, you go through this point. A sketch is kind of, let me erase that. Kind of, we have to make sure we have a, did I erase my function? Okay, so we have this point and that point and that. So let's see how I can draw this. It's kind of okay, but what happened is that it's want to show you. Yeah, it goes like that. It's hard to use a pen to sketch a smooth curve like this. Let's try one more time. Okay, let's pick that. Okay, that's better. Okay, this goes to this point and that point and that point. Okay, so this graph is your f of x, that's the b part, which is the square root of x minus 2. Okay, all right. Now, let's take another type of shift. This is horizontal shift. Okay. You have your basic function, and then when you have y is equal to x minus h, please note that where h is what? Positive, but negative. So when that happens, you say horizontal shift, but you go what? Right. Okay, you go the opposite of the sign in front of the h. Okay, so that's why I said opposite of what? Minus h, which will be positive for h. So it means you go right. Then if it is plus, is the opposite of plus h. So that will be what? You go left horizontally what? H units on the graph. Okay, so let's look at this example. This time we're going to do this separately. Okay, so what's our basic function? We have a, g of x is equal to absolute value of x minus 2. And then g of x is equal to absolute value of x plus 2. Okay, our basic function is the absolute value of what? X. Okay, so first for part A, where you have g of x is equal to the absolute value of x minus 2. Okay, this is a horizontal shift. It is horizontal shift. It's going to go left or right. Because it's what minus is going to go to the right. So it goes to right 2 units. And then part B, which is the g of x, is equal to absolute value of x plus what? S plus 2. Okay, this one is also a horizontal shift, but it's going to go left to what? 2 units. Okay, 2 units. So let's do part A here. Part A, we have this graph. Okay. So we are going to have our basic what? Function, which is absolute value of just x. Okay, so we're going to have 1 and 2. Okay, so you have 1 and 2. And over here, we also have 1 and 2. Okay, that is 1, and this is -1, -2, and then -1, -2. This is my x-axis. That's your y-axis. Okay, so first, let's draw the graph of what? F of x is equal to s squared. Okay, now x is 1, absolute value of 1 is also 1. 2, absolute value of 2 is that, is also 2. And then if it's -1, absolute value of -1 is +1. So that is also that. And then we have -2, absolute value of -2 is +2. So, and then if x is 0, is also 0. So we have a straight edge, and then we draw a straight line down in this point. Okay. And then here too, we have a straight line joining this what? This point, going that way. So this is the f of x is equal to absolute value of what? X. Now, part A says that we are moving right 2 units. Okay, right 2 units. Okay, we're going to write 2 units. So every point, these points on the curve are going to move 2 units to the right. So the origin is going to move what? 1, 2. So it comes to what? We move it to what? This point. It's going this way. Okay. Then this is going to go 2 points. 1 is at 2, and then it's going to be at what? At 3. So this is 3, and that's the point. And that point is also going to go to 1, 2. Okay. So the coordinates, this is going to be 1, 2. That will be 4. Okay. This is 4. And so that goes to this point, which is all that. Okay. Then on this side is also moved to the left. So that's 1, 2. That will be exactly at that point. And then that is going to go 1 and 2 will be what? At the what? The y-intercept. So the graph of the part A is this one. And then that goes, sorry, okay. Okay, so we have that. That's my graph. And so this is g of x is equal to the absolute value of x minus what? X minus 2. Okay, it keeps going, it doesn't end. Okay, goes up and up. All right, now part B, let's have similar thing, but this time we're going to go left 2 units because it's what? It is plus what? Plus 2. Okay, so we have this graph, the basic function. Let me erase that. I need to get better straight line. Okay. Okay. So we have this is the line, and we have that. Okay. So you have 1, 1, the basic one first. You draw that. This is -1, -2, and then the origin. Okay. So it will be 1, 1, and then what? 2, 2, -1 and 1, -2, and +2. So we have this line. And we have that. Okay. So, but we are saying this is the graph for what? The f of x, which is the basic function, absolute value of x. Now we're going to shift this what? Left 2 units. So we have this point. You're going to go left. The origin is going to go to this point and it's going to be here. Okay. So it's going 1, 2. Okay. This point is also going to move 1, 2. So you get 3 and 4, -3, -4. So this is going to be 1 and 2. So it's going to be here. Okay. And then this point is also going to go 1 and 2, which is there. Take this point. That point is coordinates 1, 1. That should be going to the left 1 and 2. So it's going to coincide with this point, which is negative, which would be -1 and then what? 1. And then this point is also going to coincide, we intersect the y-axis at what? So that's going to be 0, what? 0, 2. So let us draw these points, join them with a straight edge. So that's the 1. Okay. And that is the second one on the left. Okay. So this graph is what? The g of x, the g of x is equal to the absolute value of x plus what? X plus 2. It moves to the left. Okay. So this is we have so far talked about the vertical and the horizontal what? Horizontal shifts. All right. Next, we have this function. Okay. And they said we should what? We said grab the function f of x is equal to this. And then find the domain and the what? The range of it. Okay. But the first thing we need to do is that we have to, what's the process? If you have f of x is equal to this, x minus 2 minus 3 all squared, and then plus what? Plus 2. Okay. So what we do is that first, I'm going to put this in the steps. Okay. First, what is our basic function? Let's call it y is equal to, this is x squared. Okay. And then 2, step 2, what happens when you have what? X minus 3 all squared. What's the movement? Okay, this is the inside. So it's going to be a horizontal shift. Are you going to right or left? Opposite of negative is what? Is positive. So this is a horizontal shift. Okay, horizontal shift. How many units? It's going to be what? 3 units. Okay, we're going to go right what? 3 units. And then step 3 is that we have for x minus 3 all squared plus what? Plus 2. This is a vertical shift because of its plus 2. That's a plus what? Plus k, remember? So that's going to go up. So the vertical shift, this is up. How many units? 2 units. Okay. So this problem combines the what? The vertical and the horizontal shifts. Okay. And so let's have the graph here. We have, this is my coordinates. This is my graph. Okay, this is my graph. We're going to have, first, remember, we have the basic function, and then we move it what? Up. Sorry, we move it what? Right. Okay, 3 units. And then we move what? Up what? 2 units. Okay, so let us try to have a clean axis. Very good. Now, let us see how we proceed. Okay, first, let's draw the basic function here, which is what? X squared. Okay, x squared passes through the origin. So this is 1, 2, 3, 4, right? So every point is going to move, the second step here, every point is going to move to the right 3 units. So we have 1 is also 1. If you have 2, you have what? It's actually what, 8? So that is 4. So this is 1, 2, 3, and 4. Okay. So we have this point. 1, 1 is this. 2, 4 is that. Okay, there's a turning point here, and you're gonna have, it's a symmetric to that. Okay, this is the graph for what? For so get -1, -4, -2. This is, should draw that carefully. Okay, so we have, you got -2, -2, 4. Okay, wait, don't forget this is 2, 4. And then this is a -2, 4, and that is -1, 1. So it's going to pass through these 2 points and then go up like that. Okay. So then we're going to shift this to the right 3 units. So that means that this point, the origin, if we change the color, the origin is going to go 3 units to the right. So that goes, this point goes 1, 2, 3. So it goes here. Okay. And then it goes up 2 units. So it goes 1 unit, 1, 2, 3, and goes up 1, 2. So that is what? So the origin comes here. Okay, the origin is going to be here. Now the coordinates of the origin is going to be what? 3, and then 3 what? 3, 2. Okay. Then the same way, if you have this point, let's take this one. It goes to the right 3 units and goes up what? 2. So it has what? 1, 2, 3. That is, this is 4. Okay, and then goes up 1, 2. All right. So that point becomes, this point becomes what? 4, 4. All right. Then on the left, let's take this point, -1. The coordinates is -1, 1. It goes to the right 3 units, 1, 2, 3, and goes up 1, 2. So the coordinates of that point will be 2, and then what? 3. Okay. So you have that. And then last but not least, this point, which is -2, 4, it goes to the right 3, 1, 2, 3, and goes up 2, 1, 2. That is 6. So this is going to be 1, 6. All right. And then we have this point goes up, and it's 3. This point right here goes to 1, 2, 3. So it's 2, 4. It becomes what? 5. It goes to what? 5, and it goes up what? 2. And that is also 6. So we have this point, and then 5, 6 on that point, on that side. So this is the graph that we are talking about. Okay, it comes through this, and that goes to the point. Okay, so the points, this point is what? 1, 6. This is 2, 3. This will be 3, 2. This is 4, 4, and that is what? 5, 6 on that side. This will be 5, 6. Okay, so this is the final graph of what we know. Just should be y is, sorry, this is what? F of x is equal to the, let me write it down here. This is f of x is equal to the x minus 3 squared plus what? Plus 2. Okay, so far we have looked at the function with the vertical and the horizontal shifts, and then we look at examples that combine the two. Now let us go and look at another technique. Okay, we have another technique. Now another technique is vertical compression or stretch. Okay, and then we also have horizontal compression or stretch. Right. So here, if you have a basic function, which is that, And then you have you want to draw a new function, which is a. A is a constant, actually. It's a number in front of that. This is obtained by saying multiplying every y coordinate of the graph of the basic function by what? By a. Okay. So if your a is a fraction, it's a number between 0 and 1, this is a vertical what? Compression. Okay. And then if it is greater than 1, that is a vertical what? Vertical stretch. All right. On the other hand, if you have the function and then the a is actually inside the what? It's an inside function, okay? Then that will be a horizontal compression or stretch. Now, if a is greater than 1, that is a compression, and we multiply by a factor 1 over what? 1 over. In this case, we multiply the what? Each s coordinates. Each s coordinate. The other one is what? Y coordinate. This is what? S coordinate. Then multiply by 1 over what? 1 over a. In other words, divide the y coordinate by a. That's another way to say that. Now, it is between 0 and 1. The a, the constant is between 0 and 1. Then this is a horizontal or stretch by a factor 1 over what? A. Okay. So now, let's look at some examples. It says that use the graph of the graph of f of s given, okay, and find a. Y is equal to 3 times f of x, and the y is equal to f of x in parentheses 2 times x. Okay, as you can see, one is going to be, we're going to multiply the y coordinate for the first one. Every y coordinate will be multiplied by 3, and here every s coordinate will be divided by what? 2, or will be multiplied by 1 over what? 1 over 2. Now I want you to note these points, all the points on the graph. Okay, this is what? 0, 0. There's the x-intercepts. This is pi 0, and this is negative pi 0. So the x-intercepts, okay, as you can see, is through that. Now look at the coordinates. So for part A, what do we do? All right, you have y is giving y is equal to 3 times f of s, because the 3 is what? Outside, okay? Outside the function, we multiply each y coordinate by what? 3. And what is this? This is a vertical what? Stretch. So this is the graph that was given. So what means is that every y coordinate, we will multiply it by what? By a positive 3. Okay. So this point becomes what? 3 pi over what? Over 2. Multiply the y coordinate by 3, which is what? Which is 6. Okay. That is why we have this point right here. Then if you look at this point, it becomes, you multiply the y coordinate by what? 3. Then you have what? S coordinates is made the same, but the y coordinate will be multiplied by what? By 3. And then if you go to this point here, it also becomes the pi by what? Pi by 2. Y coordinate does not change. Sorry, x coordinate does not change, but the y coordinate is multiplied by what? By 3, which is negative what? Negative 6. And that gives me this point. This point right here is this one right there. Okay. Now, what about the s-intercepts? Do they change? Now, remember, every y coordinate is 0. So if you multiply by 3, you get 0. So the s-intercepts are the same. They don't change. Okay. And that gives us what? This graph. Okay. That gives us that graph. Next, if you have, it said that b part says that y is equal to 2 in parentheses. Okay. In parentheses, f times in parentheses 2x. Now, again, because the 2 is what? Inside the function f, we multiply every s coordinate by what? 1 over what? 1 over 2. Or you can say that, instead of multiply, you can say divide. Okay. Divide s coordinate by what? By what? By 2. It's the same way. Okay. So every s coordinate, we're going to multiply by 1/2. Okay, let's consider this graph, this point, sorry. Now, what does it become? The x coordinate, which is what, 3 pi over what, 2, we multiply this by 1 over 2. That part becomes what? 3 pi over 4. So the point is now 3 pi over what? 4, comma, y coordinate does not change. Okay, now this point, okay, this point is y x coordinate by what? 1/2. So x coordinate is what? 1/2, pi over 2. We multiply it by what? 1/2, which is what? Pi over what? Over 4. So the point becomes negative, sorry, positive what? Pi, okay, pi over, let me erase that. Yes. So it becomes what? Pi over 4, comma what? Comma negative what? Negative 2. Then what about this point? It also becomes, we are multiplied by negative pi by 2 by half, which will give us minus pi over 4. And then y coordinate does not change. But on this graph, the x coordinates will change. All right? X coordinates will change. Now, the intercept now becomes what? You multiply this by 1/2, becomes minus pi over 2 and then 0. The origin is the same. If you multiply 0 by 0, it's also 0, 0. That is why we have this origin. So this point, the y coordinate now for this point, minus pi comma 0 becomes negative pi over 2, 0. And that's what we have there. Then on the other side, this x-intercept becomes what? Pi over what? 2 comma what? Comma 0. And that's why we have what? This point. And so if you plot the x coordinates, and then it's turning at this point here, this is that, this point there is this one, and this point here is that one. Okay, and then if you graph it, that's what we get. All right. So we have what? Horizontal compression, and then vertical what? Vertical stretch, as we gave. Now let's continue looking at some other examples. Okay, it says use the graph of f of s, which is s squared, to obtain. Now you see that in this problem, they gave you the what? The basic function. And so if you have g of x, which is equal to 1/2 times what? X squared. Now notice that the 1/2 is what? Is outside. Okay, it's outside the function. So you can see this as what? 1/2 times what? F of x. So in this case, your a, according to the definition, is what? 1/2, which is between, it is less than 1 and is greater than what? 0. Okay, so when that happens, what is it? We'll find out. Okay, now it means that we're going to multiply every y coordinate on the graph of what? S squared by what? 1/2. Okay, now what type of what? Stretching or compression it is. All right, now because it's 1/2, it is what? It is a vertical what? Compression by a factor of what? 1/2. Okay, and so we're going to have this graph, all of them on the same one. The black is the basic function, y is equal to s squared. Okay, so again, remember every y coordinates we multiply by 1/2. So for this point, which is what? 2, 4, it becomes what? 2, 2, because 4 divided by 2, or 4 times 1/2 is what? Is 2. So that's why we have the 2, 2. So this point here becomes that. Okay, this point, which is 1, 1, if you multiply by 1, y coordinate by 1/2, you get 1/2. So this becomes this point. Again, on this side, this goes to that, and this point becomes what? That point. Okay, so the blue, this graph or this curve represents what? The g of x, which is what? 1/2 of what? S squared. Okay. All right. Now the final thing is reflection in the x-axis, and then what? Reflection in the y-axis. So by definition, when a function f of x is multiplied by a negative 1, then it is a reflection in the what? In the x-axis. So for example, you have y is equal to negative of f of x. Okay. So for example, when we have this graph, find the domain and the range of that. Okay. So you have f of x is what? Is equal to negative square root of what? Square root of x. Now what we do is that we want to find the what? This is a reflection in the what? X-axis because of the negative in front of it. And then we'll find the domain and the range. Okay, note that if f is basically the square root function, so we begin with the graph of square root of x. Okay, and then for each point on that, we reflect it in the what? In the x-axis. In that case, the x coordinate will be the same, remain the same, but the y will be what? Negative of that. That's what it means. Okay, so then let us go to the graph. Pick some points. Okay, you have to take the x values. Say 0, square root of x is 0, 1, 1. And then 2, square root of 2 is approximately 1.4. Square root of 3 is what? 1.7 approximately. And then square root of 4 is what? Is 1. Now, if you have negative, y is equal to negative y, square root of x, that gives out these values. And so this is the graph for what? My square root function. Y is equal to square root of x. And then when I reflect it in the x-axis, this point comes to that. This point becomes this one. This point to the other side becomes this side in that order. Okay. So that's a reflection in the what? In the x-axis. Now, what is the domain? Okay. What's the domain of x? The domain is the x values. It includes, this domain is what? It's all real numbers greater than or equal to what? Equal to 0. Okay. So that's a domain. What's the range? What is the range? Okay. That will be everything. All right. It goes, ranges from what? Negative infinity 4. We are talking about the range of the what? The resulting function, which is negative square root of x. Okay. It's going to be, everything goes up to what? Up to what? Up to 0. So that's why, including 0 anyway. That's why we have that. Okay. So now, let's talk about the reflection in the y-axis. And then we will do another example and that'll be it. Okay. For the y-axis, we have, if you have f of what? Negative x inside the function, excuse me, then it's a reflection in the what? In the y-axis. Okay. Let's take an example. It's a graph the function f of x is equal to negative x or raised to what? Negative 3. Well, notice that this will be the same as s cubed anyway. Okay. So you can say that, depends on sometimes how you look at it. Okay. But some functions, this will be the same as saying that, okay, we're going to what? We're going to reflect what? The x-axis. It's a reflection of the x-axis. All right. But this is a very simple one. Suppose we give you this, say plus 2 all cube. All right. And that's where the problem sometimes will come. Okay. So notice when it's inside a function, it's inside, or when it's what? It's outside. Okay. Right. So now our basic function is what? S cube. All right. Y is equal to s cube. That's where we begin. And then we're going to reflect in the y-axis. Okay. So for each, what happens is that for each point, okay, the y as coordinate remains the same, but the x will be what? Negative of that. Okay, and that's what this is about. It means. Okay, so to obtain the function given, we reflect it in this function y is equal to s cube about the what? About the y-axis. Okay, so here we pick some points and values. Okay, and then we evaluate. Say if x is negative 1.3, if I cube it, I get this point. So again, the black graph is the cubic function. All right. And so if you want to reflect it in the y-axis, well, the origin is the same. So take this point. If you reflect it, it goes to on the other side. So it becomes negative 1, 1. Have this point. If you reflect it, you have what? Negative 1.3, 2.2, which is this one. Okay. Then if you have this point, which is negative 1, negative 1, negative 1, it becomes what? Positive 1, 1, which is that point. So this is reflected in the y-axis. You get that. And then that point also reflected in the y-axis becomes that. So to join them smoothly, you get that this graph, which is what? The y is equal to negative x to the what? To the cube. Okay. All right. So what's the domain? The domain is, in this case, all real numbers. What's the range? It's also going to be what? All real numbers. Okay. For both, whether the cubic function or the what? Y is equal to, in parentheses, negative x or cube. Okay. So here, as a combination of what we have learned, I want to have a function said, find the function that is finally graphed after the following sequence of transformations are applied to the graph of what? Y is equal to s squared. Okay. So if I shift this, okay, it said that shift right 3 units. Shift right 3 units. Then what will be the function? See, we have y is equal to, if it's a shift, now remember, it's going to be inside. If it is outside, okay, it's going to shift right. It's a horizontal shift. It has to be inside. So this will be what? 1, and this is 3. Now, since it's going to the right, what will be the sign between x and 3? It will be what? Negative. Okay. So that is what we have. Okay. So first we have this one is a shift. Then it says that we reflect this in the what? In the x-axis. What will happen from this? The second part here, we're going to have what? Y is equal to, guess what? If it is what, we're going to break it out. Negative 1 outside. So that's x minus 3 all squared. Then it says that shift down 2 units. So that is y is equal to minus x minus 3 all squared. And then it said 2 units. Because it's going down, it's going to be what? Negative of that. Okay. So if you put all this together, I type this down nicely. Then we have this what? The following graphs. The same as, functions. Same as what I wrote down. Let me raise that so that you can see that that's why we got this. These functions. So that's your final what? After the function s squared has gone through these what? Transformations. So that's the final what? Expression for that. Okay. So our last example is to find what this transformation, what happens in this transformation. You have f of x is equal to 1 over x plus what? 1, and then plus 1. Go first, what is my basic function? What's my basic function? It is y is equal to the reciprocal 1 over x. Okay. So if you have the step 2, we have what? 1 over x plus what? X plus 2. This is the same as saying that it is what? X plus 2, like that. You can put in parentheses. And you see that this is what? Let's say a horizontal shift. It is a horizontal shift. Okay. How many units? Is it going to go right or left? Well, you have for positive 2. So that will be to the left 2 units. So this is left 2 what? 2 units. Okay. And then step 3, we have what? 1 over x plus 2. Then we are adding what? 1. Okay. Plus 1 is going to be a vertical shift. How many is going to go up or down? It's going to go up. Why? Because of the plus. Okay. Plus 1, 1 what? 1 unit. Okay, so we're going to put this together and sketch the graph. Okay, we have to sketch the graph, this graph, and it's going to go up 1 unit and going to go down. It's going to go to the what? To the left 2 units and going to go up 1 unit. Okay, so let's graph it here. So I have, this is my graph. Okay, the graph, this is a basic graph here. It's gonna be like this. Okay, this is your X, Y axis, and that's your X axis. Okay, this point, let's say 1, is gonna, this is 1, and then you have a 2. 2 is a half of that. Let's put a 2 here. It's gonna give me half of that. So this is 1 over that. So we have this point. Okay. So we'll go back to our process. The first thing is that we have to shift that to the left 2 units. Okay. So you're gonna shift this, every point here on this, to the left 2 units. So what is happening is this. Let me change the color. Okay. This axis, okay, is going to go 1 unit to the 2 units to the what? To the left. Is this plus 2? So it's going to go to the left what? 2 units. Okay. So this axis comes here. The Y axis becomes this. Okay. And then it goes upward 1 unit. So this is graph. This is a 1 there. So that's your X axis. Yeah, so your X axis now becomes what? Becomes that. Okay. So 2 and go up. So the graph, everything now becomes this, goes this way. And that becomes that. So what is happening is that this point here, okay, this point, which is 1, 1, it went out, this is there's a 1, 1 here. It goes to a 2 units, that is 1 and that, okay, and goes up what? 1 unit. So it became this point. And then this point, which is 2 and a half, okay, 1/2, it goes to the left 2 units. So that is to 0 and goes up what? Goes 1. So that is 1.5, which is right there. Okay, so this point is actually now 0, 1.5, or sorry, 0, 3.5. Okay, that's why we have that point. This graph going this way, and then also what? Coming that way, with the same or similar explanations. Okay, it's kind of messy, but at least you see the concept. This is the end, and I hope it is helpful. We'll look at other examples in class together. Thank you.